Good morning, everyone. Hi, I'm Mrs. Tan, LT Maths from Maths Department TJC. Today I'm going to talk more about this subject, the H2 Further Maths, which I think you know that all of you will be taking H2. Most of you will be taking either H1 or H2 Mathematics. So for today's sample lesson, what I'll be sharing will be maybe certain parts of the lesson whereby you can see how concepts from H2 Math can be extended into Further Maths, and that will be what you will learn. Okay, I will first share with you our Further Maths syllabus aims. Highlighting mainly is that if you have the interest in learning mathematics, in fact, doing mathematics, by attending this course, right, you will get to acquire a wider range of mathematical concepts and stronger sets of mathematical skills compared with other students. In fact, you will also be developing a lot of thinking skills, reasoning skills, and communicating mathematically, as well as applying mathematical modeling skills to approach problems that you might find unseen or maybe unfamiliar, and you have been taught all the different type of skills. And most of the problems in further maths, you will also see that usually it will connect ideas from within mathematics and across different topics. And most of them are actually results that actually can be applied in sciences, engineering. In fact, those who are interested in taking engineering, it'll be good if you take further maths, all right? So basically, this course is to allow you to experience and appreciate the rigor and abstract of the subject in maths, okay? All right. Next, what I'm going to share you is in Mathematics TJC, further maths is basically it's a H2 subject. Similar to computing, I mean, there's no H1 for the maths. If you take further maths as a H2 subject, you must take H2 mathematics. So basically, two of the H2 subject will be H2 math and H2 FM. And in TJC, the content from these two subjects will be combined, and actually we reshuffle in such a way that will be taught concurrently as two subjects, FMA and FMB. Now, what I've highlighted in blue, as you can see on the screen, are those topics from H2 math. And notice that those topics in red are those topics from further maths. So as you can see, right, as a further maths, if you take out further maths, you actually learn more and actually even deeper, compared to students who take H2 math. And also more topics, as you can see, those numerical methods and also proof using mathematical induction. I won't go down the list. You get to see this anyway if you decide to take out this subject. Okay, so let me just move on to share with you some maybe some sample question first before I share your sample lessons, okay? So that you can see roughly, if you're not sure whether to take further maths, how is it different? Okay, how are they different?
No.
Maybe someone can mute, before. Okay, let's look at this example. Now, this is a very common question that you will see if you're taking H2 mathematics, right? Whereby you will come across equations involving expressions that are not the standard polynomial or cubic quadratic kind, But because if you study H2 mathematics, all students will learn to use the graphing calculator to solve an equation, all right? So then you just need to graph out the equation of the y equal to the left-hand side expression. GC will show you the graph, and if you look within the interval whereby you have to locate the solution of the equation, here all students should be able to find this easily, all right? However, how about if you are further math students? Then the questions might change, right? What if I ask you to solve this equation for all positive real values of x? Think about this. Maybe to help you, right? What I'm saying is it only these two solutions? Right? As an FM student, you might be expected to know how to think. Can you justify that there are no other answers? I'll give you a few minutes to think, all right? If you know the graph of the equation, you know the x-intercept, gives you the roots of the equation. So how would you go about justifying that? Besides these two answers, there's no other answers. Look at the difference between these questions and the one that I showed you just now, right? Just now whereby the interval is between 0 to 4. So it's quite easy. You just conclude these two other answers. Yeah, encouraged to say out the answers if you would like to. But I'll give you a few minutes to think about it first. I've highlighted in box. So what is so special about that part? So the rigor of learning deeper is that you need to know the different approaches that you can actually justify that what I highlighted in red, in fact, will not turn, or maybe there will not be another part of a graph that may eventually cut the x-axis again, right? So this is what I meant by thinking deeper and further, because we are trying to solve and check that for all positive real values of x, there's no other solution. Understand? So definitely, if you are familiar with your A maths, like calculus, some people may think of like check whether there's any more stationary point, no? Checking, finding dy dx, okay? Or some of you might see, if you continue to go all the way down, right, this part of the graph, all the way down, you never cut the x-axis. So how do you go about proving it? All right, how do you go about reasoning that out? Okay. So I'm not going to give you the full answer to this. This is just to give you a glimpse of what exactly, the kind of mindset that you should have, if you decide to take out the subject. Okay. Okay, let's look at a sample lesson. Okay. This is this lesson, right, is actually extracted from one of quite a big topic, conics, right? And conics itself is actually a broader and deeper topic, extended from the H2 math graphing, right? This topic on graphing. Okay. In H2 math, when you learn graphing, one of the concepts you will learn will be ellipse, right? How to use the equation of ellipse and explore some of the geometrical property, right? I think in secondary school, you have learned equation of circle, right? So in JC, you go beyond that. So you learn ellipse, parabola, hyperbola. Okay. So this is a standard equation for an ellipse. Now, how about in further maths? Okay. So how do we extend deeper and further of this concept on ellipse? Basically, when you learn H2 further maths, you learn properties like this. Okay. Compare the difference. When you learn H2 math, basically you learn the equation. HK is the coordinates of this center, right? A is the distance from the center to the extreme right hand side and left hand side of this ellipse, okay? And B is here, okay? And then when you come to further maths, you go beyond that, okay? Notice that we talk about properties, right? Properties that relates to specific points on the ellipse, okay? For example, you will learn about ellipse being a locus of point. Locus of point, by the way, it means that points that move on the circumference of this ellipse, on this ellipse. So you learn properties such that points, a special point called focus, F1, F2. If you connect to a point on this locus of point P, the path here, you realize that, okay, there's some special property such as D1 plus D2 be double the length of A. And in this topic in further maths, you delve deeper into the different type of proofs relating to this, okay? So let's look at how we actually apply this. Now, further maths is not just always look at complicated expression, not to worry, okay? We always share with you, how do all this actually apply into real life, okay? So let's look at this. This is the example of how we are going to apply just now some of the properties of ellipse, which is called the reflection property of ellipse. This is a picture of the Grand Central train station in New York, Whispering Gallery. This is called the Whispering Gallery. So maybe before I tell you what this is about, okay, I'll share with you a YouTube video first.
Space, the sound dissipates square of the distance from the source, but near an arched surface the sound has different plans, proportionally dissipating from the source at hand, which means that it dissipates slower, and I can sing quiet over here, and over there the camera picks it up totally loud and clear, whispering waves, a whispering gallery. Do I still be no child here in the Grand Central Terminal? Come and whisper for a while. Rafael Guastavino came to New York from Barcelona. He had was a big innovation. So now let's look at it some more. Whisper and wave, whisper and gallery. Blue Ostavino tile, here in the Grand Central Terminal. Come and whisper for a while. Whisper and wave, whisper.
Okay, I think we are more or less covered the whole video. So let me just continue from there. Okay, notice that, in case you don't catch what the YouTube video is about, all right? Now, there's one important message that bring across to you. Not sure whether you get it. It's about if someone at this corner, let's say the red dot here, whisper to the wall, right? Then it is found that sound waves will reflect and the person at the other corner can actually hear it without having to speak very loudly, right? So why is this not like this, you know? So basically it has something to do with the structure. So just now at the end of the YouTube video, you saw them showing all the different type of the structures because of this reflection property of ellipse, okay? So let's just do some exploration. Now you might want to take out your handphone and scan this QR code and actually discover one particular property about this reflection of sound waves, what it will actually create, what kind of property would it have, okay? Give you about a few minutes to actually scan this. I hope you can, and then you might want to reset, then show the animation. In case some of you not sure how to move the point P, you're supposed to move this point P and just move your cursor to the point P and just drag it, okay? Move it a cursor along this, all right? Those of you who have actually used GeoGebra in your secondary school, math teachers, if they have done it in class, you have seen this before. So basically, if you click on show animation, you see how the sound wave, if you stand at this particular point, F1, which actually is the focus, one of the foci here, F1, F2 are the focus, whereby your sound wave, if you travel from this particular point, hit the ellipse, you go to here. And notice that what happened, what's the special property that you can see here about the two angles, right? This angle is equal to this angle, right? So this is one special property also that is shared by this, that's mentioned in this reflection property of ellipse, okay? So you can still play around with it for while I stop share and change back to my PowerPoint slide. Okay, those are done with this playing with GeoGebra, okay? You might want to read this question. So in further maths, besides observing this property, right, that this ellipse have about reflection property, we also let you have a chance to actually prove the results, okay? In class, because you learn more about properties of ellipse, so actually the ratio of the length of PF2 over NF2 and PF1 over NF1, this one is usually you will have be asked to prove, but here we'll give you as a result first. Okay, so in this example, we say that this ellipse is in a standard position, meaning that the ellipse has a center at origin, right? The 2 points F1, F2 has coordinates, that is actually such that this distance C from the origin, right? On the x-axis as well. So P is supposed to be a point on the ellipse in general, and you're supposed to prove that if N is such that it's a point whereby the normal, right, to the tangent here, this is a tangent here, okay, this normal will cut this x-axis as point N. You have to prove that angle NPF1 is equal to NPF2, okay? Now, maybe you can think about it. Now, in class, usually what we'll ask is to get students to actually brainstorm. You don't have to tell me how to prove it first, okay? Maybe you can think about what are some of the questions you have about this problem. Is there anything that you're not sure? Any condition, anything that you might want to clarify? Or you might have certain ideas come to you, oh, maybe this is the way I prove this question. Okay, maybe you can give it a try and just use this QR code and key in what are some of your possible explanation questions to this problem, and then just submit to me before I share with you what are some of the responses that we key in. Okay, give you a few minutes to think about this and key in some of your preliminary ideas. To prove that this angle F1PN is equal to NPF1, these two angles. And this is a given condition that the ratio of the two lengths here are the same. If you have your friend next to you, feel free to discuss with them. Okay, some responses are coming in. Okay, I'll share you some of the responses later. Okay, give you another half a minute. Do not need to write out the whole proof. Okay, it's too long to really spend this time to write it out. Okay, it's more of thinking and asking questions. Okay, those who have absolutely no idea, okay, I think I'll share you some of the responses. In fact, some of the responses that I have are similar to those that I have collected over the years from some of my students. So some of this are the responses. You can take a look. The question is, these are some responses, but they may not be always correct. Okay, are you possible to show show that triangle, the two triangles? Okay, in fact that's a typo. Show the two triangles that are congruent. Is it possible? What do you think? Could they be congruent? Take a look. They may share the same ratio, but does it mean that the numerator are the same? Okay, those of you who use numbers, use simple example numbers to understand this, you realize that it's not possible, right? Because as your P move, your N, right? Your N may not be the midpoint of F1, F2. Okay, so no, right? Second one, can we actually find the length of NF1 and F2 show that the two lengths are equal, then the two angles will be equal? Do you think this is true? May not be again, right? Since the two triangles may not be congruent, okay? So this might not be true. Okay, next question. Can we use sine rule? Okay, let's hold this first. Maybe, yes. But if you think of certain rules, so which triangle are you trying to explore? So this should be the next question you should follow up, right? And hold on to that. And somebody may ask, can we apply properties, angle property of circle here? But this is an ellipse, right? So actually think carefully. Ellipse actually is more general than circle, right? In fact, the answer is no. You might want to explore further. Why is it no? Okay. Those of you who think along the line of sine rule, yeah, more or less there. Okay, but you must identify which side to choose to apply sine rule. Okay, so basically what I'm actually showing you is in class, for the math students, you will discuss and come up with a lot of questions, and you should learn how to solve questions. And as you brainstorm ideas, we lead to a solution plan. Okay, which you can actually further proceed. So we don't expect you to do things like what I'm going to show you a solution to straight away come up with answer like that. For example, using sine rule. Okay, but think, if you use sine rule, which triangle should we choose? And what's the aim of the question? We will always revisit the aim of the problem, right? So you can apply sine rule to this triangle F2PN, for example. You don't really need to have numbers. I thought a lot of you are more familiar with numbers in secondary school. So doing a proof, all this, usually we just leave it as it is, like finding sine or angle F2PN, finding sine angle PN and PF1. Then from there, our aim is to equate the both, right? So in class, what is the highlighted in blue will be what we're trying to link, right? To eventually show that it can be proven that this is actually equal to sine angle PNF2. Okay, so this is just an illustration of in further maths what you will learn to do. You may not be expected to know how to do it right away, right? Because you don't forget, further maths concepts are all built on H2 math concepts. So it's more of the skill set actually. With practice, more practice, you really experience what we meant by developing thinking, reasoning, and communication skills to help you to write proof. And it really help you to think about how to make connections between different concepts. In fact, right, just to share with you, this result is also what we call the angle bisector theorem. Okay, so in class, you will learn, this is this theorem. And also, we won't stop there. Okay, we won't stop here. You will also explore alternative proof. Okay, those of you who thought of congruent triangle, will say, no, not possible. But some of you may argue, how about, can I consider other congruent triangle? Maybe I extend F1P further to F3. Can I try to prove, say, let's say F3PQ, where F3 is a reflection of F2 in the line T? Is it possible to prove that something congruent, then beta is equal alpha, so beta is gamma, things like that. Yes, possible. So again, this, what I'm showing you now is alternative proof. You will learn how to do this eventually in further maths, okay? To write out mathematical reasoning, okay? To establish a result, okay? So you have all these kind of opportunities and you can get to learn and enjoy the process as well, okay? All right. I'll just do a quick, because actually I wanted to share you something else. In further maths, it's not all about geometry. Just don't be mistaken. This is just one small part of a further maths topic. Okay, so you also learn other things like, for example, in the topic of differential equation. You see how you can make prediction of population growth, right? How do mathematicians predict in the year 2100, how will the population become? So we actually apply this in other topics using topics in graphing, and maybe integration. So it's not all about geometry, yeah, okay. So in the topic of differential equation, I just highlight the differences. You learn first order linear, simpler DE, right? In H2 further maths, you learn second order DE as well as learn how to solve more nonlinear DE, okay? This one I just share with you very quickly since it's almost time, okay? So in H2 math, for example, you learn how to solve a problem like this, all right, using analytical method integration, okay? And so basically you talk about an equation involving a rate of change of population in time, and then you solve it and find P in terms of T. So I want to show you the solution, but in further maths, what you learn is without even to solve it, you get to interpret how you transform a graph of dp dt against P to become a graph of P against T without even solving the equation, and make prediction of the population, right? Like as time in the long term, how does the population changes depending on the initial population, okay? So this is just a quick run through of what other things that you will also learn in further maths, okay? So lastly, in conclusion, right, if you really enjoy in-depth study of mathematics, like to do maths, okay, especially, and you like to experience different problem solving approaches, geometrical, numerical, algebra, etc., join our further maths family. All right, we welcome you. And similarly, we will have selection tests, right? And the selection test also is after you have indicated, you come and take the test and we see whether you're suitable. The test basically will test on your problem solving skills, definitely algebra skills,